Hello there, and welcome back to another video of World AI News. Throughout history, gazing up at the night sky has always ignited that sense of wonder and curiosity within us. And guess what? That curiosity is still alive and well today. Thanks to the marvels of modern technology, we've harnessed the power of artificial intelligence to embark on an extraordinary journey of exploring the universe. From the realms of robotics and satellite operations to the intricate world of data analysis, galaxy mapping, and even the quest for extraterrestrial life, AI is our trusty companion as we venture into the mysteries of the cosmos. So in today's video, we're diving deep into the incredible ways AI is steering the course of space exploration and painting a picture of the captivating future that awaits us among the stars. Let's blast off into the cosmos. When we point a radio telescope towards the celestial expanse, it's as if we've plunged into a realm of auditory chaos. The skies are brimming with a symphony of radio emissions, from pulsars to radio galaxies, atmospheric disturbances to our own technological interference. Our cosmic soundscape is anything but silent. Yet amidst this sonic tapestry, there might be a proverbial needle in the haystack, a signal from an extraterrestrial civilization. For over 6 decades, scientists have diligently scrutinized the heavens in search of signs of alien life, but the universe's sheer vastness, with its multitude of stars and radio frequencies, coupled with our relatively limited exploration, have made the hunt for ET an extraordinary challenge for human observers. Fortunately, we now have a non-human ally in the quest: artificial intelligence. AI is making significant strides in the realm of space exploration, particularly when it comes to the analysis of copious data generated by telescopes, satellites, and rovers, significantly enhancing our ability to spot potential indicators of extraterrestrial existence on distant worlds. One of the most exhilarating discoveries in the quest for extraterrestrial life took place in 2015 when NASA's Kepler spacecraft detected Kepler 452b, an exoplanet located approximately 1,400 light-years away from Earth. Often referred to as Earth 2.0, Kepler 452b stands out as one of the most Earth-like exoplanets found to date. It's roughly 60% larger than Earth and orbits a star quite similar to our Sun, rendering it a prime candidate for potentially hosting life. Yet, discerning signs of life on an exoplanet is an intricate challenge. Scientists primarily seek out life indicators by examining biosignatures, chemical or physical cues that might hint at the existence of life. For instance, a planet with an atmosphere rich in oxygen could signify the presence of photosynthetic organisms. To tackle this task, AI plays a vital role in scrutinizing data collected by telescopes and satellites to identify these biosignatures. One promising AI technique used in the pursuit of biosignatures is machine learning. Machine learning empowers computers to learn from data without explicit programming. Scientists can train machine learning algorithms to spot patterns in data that may suggest the presence of life. For example, if certain atmospheric conditions are frequently associated with life on Earth, machine learning algorithms can be trained to recognize similar conditions on other planets. Another way AI is playing a significant role in the quest for extraterrestrial life is by analyzing data collected by rovers on Mars. Mars stands out as one of the most enticing candidates for discovering life beyond Earth due to its striking resemblance to our planet and our solar system. Nevertheless, shifting through the vast amount of data gathered by rovers on Mars can be a formidable challenge. The data is frequently riddled with noise, and the sheer volume of it can be overwhelming. AI is being harnessed to automate the analysis of this data, streamlining the process for scientists in their quest to spot potential signs of life. But that's not all. NASA leverages AI in multiple facets of space exploration and research. The application of AI extends to space mission planning, a complex endeavor involving considerations like fuel consumption, trajectory calculations, and site selection for landing. Through AI simulations and optimizations, NASA enhances its decision-making process for mission planning, resulting in more informed choices. In space, AI supports astronauts' daily duty, with NASA's development of an AI system called AstroBee. This technology assists astronauts in tasks like inventory management, item retrieval, and environmental monitoring. By delegating these routine activities to AI, astronauts can allocate their time to more complex tasks, enhancing productivity during their space missions. Additionally, NASA employs AI to monitor Earth's environment. The agency operates a constellation of Earth-orbiting satellites that gather diverse data, ranging from ocean temperatures to ice cap measurements. AI algorithms are instrumental in analyzing this wealth of information, enabling NASA to make more accurate predictions about weather patterns, natural disasters, and environmental transformations. And here are some other ways where AI is used in space exploration. Personal assistance in space. In the realm of space exploration, AI serves as an indispensable personal assistant to astronauts. The concept might seem familiar to fans of the movie Interstellar, where the robot assistants TARS and CASE played a crucial role in supporting Joseph Cooper's team of researchers on their quest to find life on other planets. Interestingly, in collaboration with the German space agency DLR and Airbus, IBM has brought a similar idea to life with the creation of the Crew Interactive Mobile Companion, or Simon for short. Simon is a spherical AI robot designed to interact with astronauts aboard the International Space Station. This technology addresses several challenges faced by astronauts during extended missions, particularly those involving communication delays that hinder immediate support from mission control in both emergency situations and day-to-day mission activities. Simon steps in as a personal assistant, swiftly retrieving information for astronauts. For instance, if an astronaut working on an experiment at the ISS has a query related to the project, Simon can provide the answer without the astronaut needing to interrupt their work. Float over to a laptop and search for the information manually. Much like asking Siri or Alexa a question and receiving a prompt response, Simon streamlines the workflow for astronauts, making their missions more efficient and productive. Processing satellite images. The volume of data generated by Earth's satellites is nothing short of astronomical. To put this into perspective, consider Maxar Technologies, a space technology company headquartered in Westminster, Colorado, which boasts a library of images exceeding 110 petabytes and continues to add over 80 terabytes of data each day. Access to data center services is paramount for emerging satellite startups like Planet. In the realm of astronomy, AI technologies have already proven their mettle by detecting phenomena such as black holes and radio galaxies. AI tools are instrumental in dissecting data collected from the Gaia Space Telescope to unearth new stars that can shed light on the origins of our galaxy. Before the integration of AI and machine learning, scientists could only identify approximately 100 stars. However, thanks to these cutting-edge AI technologies, that number has surged to an impressive 2,000 protostars. Space communication. Artificial intelligence plays a crucial role in enhancing communication not only between spacecraft and Earth, but also among different spacecraft. AI can fine-tune communication aspects such as bandwidth, frequency, power, and modulation to optimize the efficiency of these links. Additionally, AI can bolster the security and reliability of these communication channels by swiftly identifying and rectifying errors or interference. An excellent illustration of this is NASA's employment of an AI system known as Deep Space Network Now. This system is adept at monitoring and forecasting the status and accessibility of communication antennas, ensuring smoother and more reliable communication for space missions. Satellite operations. Artificial intelligence is also at the forefront of a transformative shift in satellite operations, offering more efficient, intelligent, and expedient solutions for managing these complex systems. A case in point is SpaceX, which harnesses AI-driven algorithms to enhance the navigation of its satellites, ensuring they steer clear of potential collisions with other objects in orbit. These sophisticated algorithms draw upon data from the satellite sensors, such as its precise position and velocity, to pinpoint potential collision scenarios and initiate evasive maneuvers. In response, the satellite's onboard computer swiftly takes command, making real-time adjustments to its speed and trajectory to avert impending collisions. Furthermore, AI proves invaluable in streamlining the process of positioning satellites accurately in their designated orbits. By optimizing these orbital maneuvers, AI helps reduce the consumption of fuel and shortens the time required to reach the desired orbital positions, making satellite deployment more efficient. Charting the cosmos. Astronomers have also harnessed the power of AI to chart the cosmos, aiding in the recognition of intricate patterns within star clusters that comprise distant nebula and the classification of other deep space phenomena. Notably, NASA's Kepler telescope employs AI to pinpoint potential planetary locations by analyzing variations in the light emitted by stars an indicator of planets traversing between these stars and our observation. AI also plays a pivotal role in predicting the behaviors of stars and galaxies, offering insights into the probable locations of cosmic occurrences like supernova. Moreover, AI's application extends to the detection of numerous black holes through the analysis of gravitational wave ripples generated when these enigmatic entities collide with neutron stars. And far from stopping there, science is now aiming to venture beyond the event horizon of black holes with the help of AI. This ambitious undertaking will also incorporate quantum computing and has the potential to aid physicists in resolving a major challenge: the unification of Einstein's general theory of relativity with the standard model of particle physics. Furthermore, there is optimism that AI will play a crucial role in measuring the universe and enhancing our comprehension of its size and shape. Recent research conducted in Japan has harnessed AI supercomputers to analyze astronomical data and create simulated maps that closely resemble the known universe. This breakthrough enables us to anticipate aspects of the universe that extend beyond what we can currently observe due to the limitations imposed by the speed of light, which defines the observable universe. If you share our enthusiasm for AI's promising future, drop a comment below. To stay informed, subscribe to our channel, hit the like button, and turn on notifications. Thank you for joining us on this captivating tech odyssey. Stay tuned for more mind-expanding videos.